Saether. I come from Nordic Semiconductor, running long-range product management in Nordic. And today I will talk to you about non-terrestrial standardized connectivity as part of our cellular and where the market is and how to get going. So for those of you that don't know Nordic, we are a fabless semiconductor company. We've been around for around 4 decades, headquartered in Norway. What we do, we build wireless system on chips, where we build wireless SoCs with Bluetooth connectivity, long-range radio connectivity such as cellular. We have Wi-Fi and non-terrestrial. And then we are definitely a leader in Bluetooth Low Energy today with roughly 30% of the market and growing a lot on Wi-Fi and cellular. So today, let's see, I will talk about NTN and why I think that's really something that can help everyone to get connected. Part of the vision for Nordic that we will get everything connected, something in the future, basically. So when we talk about satellite connectivity, we talk about non-terrestrial networks, and what I will talk about is really standard connectivity to satellites. And why satellite connectivity? Obviously, because most of the world today don't really have connectivity for cellular. So either there is no connectivity at all, or you have to set up your own private network, which you can do, obviously, if you have a lot of devices close together. But if you will have devices all around the world, it's really hard for you to build your own network. And when we look at the future, everyone wants to really put devices everywhere around the world to help people on supply chains or whatever it is, and they need connectivity. Secondly, when I talk about something connected to a satellite, I talk about narrowband IoT to a satellite. So that is basically something that GDPP, they basically build that and make it as a standard things from release 17 a couple of years ago. And that's very, very important because when it's part of cellular and part of 3GPP, it means that whether you start connecting to a Skylo, to an Iridium, to a Myriota, or whoever else puts satellites up there, you don't have to work only with them. Because this is basically for you, satellite, very complex. You have different types of satellites, but for you guys, this is narrowband IoT, and that's how you should think about it. It's only narrowband IoT to a satellite. And that means that going forward, you can go to a Skylo or whatever, and then you can go to someone else because everyone supports standardized narrowband IoT. So also when Nordic, when we want to do non-terrestrial, we really focus on standardized connectivity, so that when you have a SIM card with narrowband IoT, it doesn't make any difference whether it's Vodafone or a Deutsche Telekom, or it's a satellite IoT or a Skylo or whoever in the future. And then, as I said, there's a lot of places in the world where you don't have any connectivity at all. And there's a lot of places in the world where you have some type of connectivity, but maybe not that good because not a lot of people there, or the carrier or the MNO that are there, they haven't focused on connectivity there. And in non-terrestrial, it means that you have a possibility to basically go to market with cellular. You can start with what we call terrestrial now, where you have a Vodafone or a Deutsche Telekom or whoever you would like to use. And then if you're missing connectivity because they don't really have connectivity right there, then you can go to satellite and connect. Standardized with narrowband IoT to send data if you have to send data, if you want to do and use a satellite. When we talk about satellite, we typically talk about 2 types of constellations on satellite. It's GEO and LEO. GEO is basically something that is available today. It's commercial, like with Skylo, so you can go and buy a SIM card to connect you to Skylo and start working with NTN today. So that's one of the good news with GEO. The other good news is that these satellites, they're very high up, so that from the world, they look like they are basically on the same places all the time. That means they're easy to find. Latency is very low because these satellites, they basically, you send data up and then you basically ping it back to the world right away. So it's very low latency for you. So if you have a use case that you need very low latency, geo-based satellites work very, very well today. And if you are under that satellite, obviously it's visible all the time. So you know where the satellite is, it's very easy. It's easy for us as a chipset and a module company to find that satellite and send data to it. But they're very, very far away. 35,000 kilometers. You know it's really, really hard to send data so high up. And that means that on a high level, we expect plus minus 1 kilobit per second from a geo satellite. And we expect that the capacity will be limited on those satellites. Also because I don't think you will see thousands and thousands of geo satellites up there at some point. But when I say 1 kilobit per second, it can be 2, it can be 5. You know, you can build huge geo satellites that have a lot of bandwidth. But on a high level, limited bandwidth, far away, easy to find, and low latency is what you get from a geo satellite. And something that works today because it's kind of simple. And then you have low Earth orbit. That really is also from a Nordic point of view. In the longer term, we think the vision is that that's really what most of the IoT devices would like to do. This is because they are closer, a higher link budget, and we expect that you can get, let's say, from a new satellites built for this, 20 to 40 kilobit per second, which basically is similar to what you get on narrowband IoT in terrestrial, which means that the use cases for you is a lot more maybe than for a geo-based satellite. Obviously, they go very fast. So the visibility for these satellites is 2 to 3 minutes when it goes on the world for a device itself. So it's really, really hard. When you have 10 satellites, like satellite IoT, they have 4 satellites. So when do you find that satellite? How do you connect to it? That's really, really hard. But the good news is that's not something that you guys need to figure out. It's something that we will figure out. So we will figure out, just as for GPS, when is the satellites on top of our, we can see it from a device point of view, wake up, because the device typically sleep to save power, wake up, send data to the satellite, and go to sleep again. But these satellites, they also need to go around the world, and then they need to find somewhere to send the data back to the world, and that can also take longer time. So this is typically not very low latency today. It can be minutes or hours before you get the data into your cloud, basically. But that will become better and better as there are more and more satellites out there. Iridium, for example, they have 60 satellites today. So they can also send data between the satellites, meaning that if there is not, that satellite can't send data down to the world right away, they can send it to another satellite that can send it down. So you will see latency come from maybe minutes or hours today even, to minutes to seconds in the future with LEO. And that's why LEO will become better for people that want lower power, higher data rates from day one, and it will become better and better on latency, in my view, going forward, because I also see where people invest today on the satellite side is really on the LEO, even though the reason it's not available as soon as GEO, it's much, much harder to make this to work. We expect that we can get access to customers to start LEO also maybe around end of this year, and that definitely we will see commercial solutions next year on LEO. There are 2 major use cases that we focus on. There are remote sensing. Obviously, you want to put things wherever in the world and send a limited amount of data. And this is the leading use cases we see. People that say that, as today, I can't really build a private network, or I don't want to build a private network. I need to digitize my company and do something with it. And then what we see coming more and more is people that build asset tracking, because they want to send things global, and it's really hard to find something that really works globally today, right? Cellular is kind of global, but it doesn't work everywhere. You don't have coverage everywhere. You have LTM somewhere, you have narrowband, you have Cat 1 bis, even 2G somewhere, you have 5G coming, so it's going to be hard to really find something that is really, really global, also for cellular. And there where NTN comes in and can be your help to get global connectivity, also if you have that. So where are we today, and how can you get going? I think that's also probably a question that a lot of people have, because even if I talk high level today, I know many of you probably have 100 other questions on how this really, really works. So today we have a standard LTM Narrowband IoT module called NRF9151. It's in production today, and that is ready for non-terrestrial. It supports the bands that you need for non-terrestrial, and we know that that can be used commercial for non-terrestrial. So our plan is that we will update that on firmware, so we cover LTM, Narrowband IoT, Geo, and LEO, NTN, and GNSS as one module. So you can go to market and build something if you want only terrestrial, or terrestrial and narrowband, or non-terrestrial, or only narrowband, only non-terrestrial. We have some beta firmware, and we have kits available now. So basically from now in end of Q3 into Q4, everyone that want to test this with Nordic, they can get a kit from Nordic and documentation and firmware to start testing, and a SIM card from an operator that also have agreement with Skylo to roam to Skylo. And as we get certified with Myriota and others, there will be agreements on roaming, so you can also test with other satellite guys out there. And we expect that firmware to be mature to the sense that we can commercialize it in Q1 of next year. Commercial means that it's certified with Skylo, with Myriota, and maybe some of the other satellite guys that have their own certification. And it's certified with the major operators, like Deutsche Telekom, Vodafone, AT&T, Verizon, those major guys. So we know the maturity, and it's really, really good. So then we will release it commercial by the beginning of next year, and then expect to do some photos with some fixes and things over next year. But it means that you can start today if you want to. You can build and plan to go and commercial from beginning of next year with a module that you put on your PCBA, basic today. This is the module, the smallest and lower power that exists for cellular today. Really low power, really great radio performance. Today, this is certified globally, both regulatory and with all the major operators out there. And when we release this new firmware with non-terrestrial, we're going to redo all that global certification, so it will be a globally certified module for you to use wherever you want in the world. Inside this very, very small module, there's also a Cortex-M application domain with a megabyte of memory. So you can use that to integrate your own application using our open SDK, so you don't need an external host. You can take that, build your small asset tracker or a sensor, connect to satellite or terrestrial as you want, with whatever sensor you want, and start sending some data. And go out there and really build something that can work really, really globally in the future. All right, that's all I had. So if you have any questions or anything, ask now, or you can ask me later.
Does it require any different antenna changes?
Yeah, so the question, does it require a different antenna, which is a very, very good question. So the non-terrestrial bands, they are somewhat different than terrestrial bands, but they are also close to terrestrial bands. So I think the answer will depend on what type of antenna you will have and what terrestrial and non-terrestrial band you're going to support. So today, if we look at our kits, for example, we have built those kits only for terrestrial today with very small antenna. But we see for S-band, for example, around 1.6 gigahertz, it works really, really well. So we can connect to a Skylo satellite, 35,000 kilometers up there, with a really, really small antenna. But we see also that if you want to do L-band and the other bands, we need to redo that antenna. But we think on a high level, you would need an antenna that has some optimization for those bands, whether it's a really small integrated antenna or it's an external antenna. And we expect that you will see from the antenna guys to see more and more optimized antenna that are better and better for satellites going forward. And then it's a discussion between you and the antenna vendor you use. Do you want to spend more memory, more money to maybe have a really good antenna to save power, or do you want to have smaller antenna and more optimized? And so I think on a high level, that's a bit how I can answer it today.
How this compares with LoRa modulation, like the Ferino Mobile?
Yeah, the question is how it compared to LoRa modulation. Yeah, on a kind of high level, I can say it's very, very different in terms because LoRa, you basically, I think, I don't know LoRa that well, but I think you just basically, you send data wherever you want, and you expect the satellite to pick it up. But this works like cellular. So you actually ask the satellite to attach, satellite say you are ready to attach, and then you send data. So it's kind of different how it works. So what you see in LoRa is really much simpler, I would say, than Narrowband IoT from a technical point of view. All right, I think time is out, but I'm out afterwards if you have other questions. Thank you.